So again we will see here another problem, that is prove that for all x p of x conditional q of x comma for all x r of x conditional negation q of x implies for all x r of x conditional negation p of x. So here, since because we have got two premises, and with that we can be able to get the conclusion part straight away, and we will apply direct method here, right. So direct proof we will give here. So whichever proof we want to apply, we can apply, nothing harm in it. It is not the thing that one has to use only direct or indirect, whatever thing we are very much familiar, accordingly we can do it. So now here serial number, statement, then explanation. So it is also not again a mandatory rule that one has to go and take the premises one by one in an order. No, it is not like that. So according to the conclusion part, we will be seeing it, and it is a random manner we can pick up the premises, more preferably in such a way that we can apply any of the law of implication and equivalence in order to get the conclusion part. That's the trick here. So now we will have this for all x p of x conditional q of x. What is this called? This is rule P. I am inserting the premises here. So whenever a premises is inserted, the explanation we will have to give here is rule P. And next is, before we apply any of the laws of implication or equivalence, one has to remove this quantification symbol. So if you want to remove the quantification symbol, what we should do? So that is universal specification on 1. So which means that from the generalized one, we will be pertaining to one single object. So I will be changing this x also. So instead of this, I can have it as p of b conditional q of b. And now we can go for the next premises, that is for all x r of x conditional negation q of x. What is this called? This is rule P. And now see here we have got, again we will, even if we want to apply laws of implication and equivalence here, I will have to remove this quantification symbol. So that is US on 3. We will have it to be as r of b conditional not q of b. So we have taken the two premises, and we are not left out with any of the premises. With this you must be able to get a conclusion part, and see to that how do we arrive the conclusion part. So if I keep these two as it is, I cannot apply any of the laws, right. So here I have q of b. At least if this premises starts with q of b here, I can apply chain rule. So if it should start with q of b, what should I do here at this point? So apply contrapositive, good. So contrapositive on 4. So contrapositive means what? See, whenever I have p conditional q, contrapositive says that that direction as well as the sign will also be changed. Negation q, conditional negation p. So that this it will be what here? Q of b conditional negation r of b. So for these two steps, can I apply the chain rule now? See here, this statement ends with q of b and this statement starts with q of b. So that is chain rule is what here? So let me tell you that. So already we have told everything. Chain rule is p conditional q and q conditional s will imply what? Q conditional s, right? Chain rule is whenever we have p conditional q and q conditional s. See here, the first statement ends with then part is q, and then the first part here is q. So therefore it implies p conditional s. Likewise these two, if we apply it, we have p of b conditional negation r of b. That is chain rule on 2 and 5. Chain rule on 2 and 5, we get that. So again see to the conclusion part, no? So the conclusion part has r of x in the if part. So then again I will apply the contrapositive. Contrapositive on 6. Contrapositive on 6, we have r of b conditional not p of b. So r of b conditional, fine. So next is we should have here, see the conclusion part. Conclusion like we have got the universal quantifier symbol. So therefore we should have here the universal quantification, for which I have to generalize from the specific object to generalizing term I will have to have. So UG on 7. So UG on 7 we will have for all x, R of x, conditional, negation, P of x. See here, that is what the conclusion part of the problem. So therefore, this statement is also valid. Understood now? So now I hope definitely you will have an idea when to go in for direct proof and when to make use of the indirect proof, and how to prove it is a valid statement or an invalid statement, right? So still, if you have some more doubts or some more queries based on these type of questions, we will have one more problem also. That is, prove that negation P of AB follows logically from for all x, for all y, P of x comma y, conditional W of x comma y, and negation W of A comma B. So what's the difference between this problem and the problem, whatever thing we have solved so far? So whatever problem we have done so far, it all has only one place predicate. What is meant by one place predicate? That is, any statement which has one subject with one predicate. It is called as one place predicate. So as I have said earlier, Zahir is a bowler. So what is subject here and what is the predicate term? Subject is Zahir. And what's the predicate term? It is bowler. So therefore, we have one subject and one predicate. So it is one place predicate. So how do we symbolize this statement? We'll be writing this to be as W of B of bowler is predicate term. We have it to be as capital B, and the subject here is what? Zahir. Zahir will be represented by Z. So then we will be representing it to be as B of Z. So likewise here also you just look into the statement, no? So if we just look into the statement, we have negation P of A comma B, which means that it is a two-place predicate term. So how do I say that it is a two-place predicate term? So there are two subjects. There are two subjects connecting to a predicate term, right? So I have also given an example as that Jack is taller than Jill. So Jack is taller than Jill. So Jack I have represent J1 we can represent to be as Jack. J2 I can represent it to be as Jill. So Jack is taller than Jill. How do we represent it? So what is the predicate term? Predicate is taller than, and the subject here we have as Jack and Jill. So which means that it is a two-place predicate. This predicate is in between the two objects or two subjects. So that is why it is called as the two-place predicate term. So how do we represent it? So taller. Taller is the predicate term. So capital T, right? Of Jack. Jack is what? J1, comma J2, right? So now I can say that Jack is taller than Jill. So this is how we will be symbolically denoting it. So whenever we have two subjects or objects followed by the predicate term, it is called as two-place predicate. So look into this problem now. So we have negation P of A comma B, which is we have got two subjects which is connected with a predicate term. It is called as two-place predicate. Whereas here, if you see that you have got only P of X or Q of X, wherever so far, whatever problem we have done so far, we only have it as a one-place predicate term, and this is two-place predicate, right? Two-place predicate. So that is what we are going to do here. So we are supposed to prove this. Serial number, statement. So now this should be the conclusion part, and these are the two premises given, and also here they have taken two subjects to be as A comma B or two objects to be as A comma B. So let me see. So it is for all x, for all y, we have P of x comma y, conditional W of x comma y. So we have taken the premises as it is and inserted at this time. So therefore it is rule P. Now that I will have to remove off these two quantification symbol for the two variables or for the two subjects or objects x, y, and I will have to. So now whenever I am going to remove this quantification symbol, I will have to specifically point out this x is some specific object or subject A or B. So that is what is mentioned here. So US on 1. So US on 1, the simultaneously both the quantification will be removed off, and I can write this to be as P of A comma B conditional W of A comma B. So I cannot have some other term other than AB. Why is that? Already in my conclusion part it is pertaining to only the two objects AB. So whatever objects I have in my conclusion part, accordingly I will have to change it. So now the third one, we have one more premises as negation W of A comma B, that is rule P. Next is, what can we do with these two terms, right? So I have got something like P conditional Q I have got, and negation Q I have got. So what can we do with these two? So what is that law called? Already I have given the list of laws of equivalence and implication. What is this law pertaining to? Whenever we have negation Q and P conditional Q, that is called as what? Modus tollens. So modus tollens la we will have only negation P, modus tollens. So I am applying that modus tollens here, so that I will get it to be as negation P of A comma B. So modus tollens I have applied for the second and the third step, and with that I am able to get negation P of A comma B. So see here, that is the conclusion part of the problem. So therefore the statement is valid here, or we have proved the given statement. Understood now? So this is the difference between the one place predicate and the two place predicate, right? So whenever you have a one place predicate, keep always in a mind that it is a very interesting thing now, as every student here is involved into the cricket game. You can have one place predicate term example to be as Zagir is a bowler, and two place predicate you can have that Jack is taller than Jill. So keeping this into the mind, we can do this problem. So again we are given here with the prove that there exists x P of x and Q of x implies there exists x P of x and there exists x Q of x. So look here, I have already given you a hint, this is somewhat a tricky problem. So whenever we have got only one premises, and with that if you are supposed to get the conclusion part, rather than going by direct proof, you can go by indirect proof and get the conclusion as F. That will be the easiest way one can do it. So already we have done a problem of that kind. If you want to do it by direct method also, we can do it, nothing harm in this. So we will go by indirect method. Indirect proof. So serial number, statement, explanation. So now what is the first and foremost point in the indirect proof? That is, we will have to take the conclusion negation part, right? Negation of the conclusion should be the first and foremost part in the indirect proof. So now I will take negation of there exists x P of x and there exists x Q of x. That is negation of conclusion. That is negation of conclusion. And next is that, what should I do with this? Apply De Morgan's law. So apply De Morgan's law. De Morgan's law on 1, what do we get? Whenever we interchange the quantification with the negation, the quantification will be interchanged, or it will be a complement of its own. So the complement of this is for all x, not P of x, and here we have, instead of and, it will become or, and here we have for all x negation Q of x. So the third point is that we will have to remove of this universal quantification, that is universal specification on 2. So we will have negation P of A. So whenever we are generalizing from generalizing part, if we are moving on to the specification part, we will have to change the variable also, so that we get this term, right? And then again see to that I can apply the conditional equivalence here, conditional equivalence on 3. So conditional equivalence, what does it say now? So whenever we have P or Q, the conditional equivalence says that we can write it to be as negation P conditional Q, right? So here I have, instead of P, I have got negate P of A, and instead of Q, I have got negate Q of A. So if I apply the conditional equivalence here, what do we get? We get it to be as P na, not P. Not P na, I have P. So P of A conditional, this Q will be as it is, so not Q of A, right? So next, again I will be taking the premises given. So that is, there exists X, P of X and Q of X. So that is rule P. Again you see, if I want to apply any of the law, I will have to remove this quantification symbol, that is ES on 5. ES on 5, what do we have? P of A and Q of A, right? P of A and Q of A. And next is, I can apply the conjunctive simplification on 6. Conjunctive simplification, what does it mean? Whenever we have P and Q, it can be written as either P or it can be written as Q. So that way if I write now, I will have P of A and Q of A, I will have, right? This is conjunctive simplification on 6. So after that, my intention is to get the conclusion part as F. How do I get the conclusion part as F here? Look at these two statements, na? 4 and 7, right? 4 and 7. So whenever I have P and P conditional Q, law of detachment, what does it say? I will have it as only Q. So now I have P of A, comma P of A conditional, negation Q of A. So that I get negation Q of A. Here the explanation is detachment on 7 and 4. Detachment on 7 and 4, we get that. Now again our intention is what? Our intention by indirect proof, we should get only contradiction. So we will take conjunction of these two, Q of A and negate Q of A, right? So this is contradiction on 8 and 9. So contradiction on 8 and 9 is what? So this is Q and negate Q, that is F. So here, sorry, I have to write here as conjunction on that, and final thing is contradiction. So with this I am able to get the final result as F by means of indirect proof. See to the next problem. Show that there exists X M of X follows from the given premises. This, I hope it is similar to the previous one problem already we have done. There I have specifically pointed out to one particular object, and here it is in a generalized form. So this very well everybody can do what? Serial number, statement, explanation. So now this is our conclusion, and these are the two premises given to us. So we will take the very first premises for all X, H of X conditional M of X. So that is what your rule P. And next is, we will have to remove this universal quantification symbol if we are in need of applying any of the laws of implication or equivalence. So if I want to remove that, it is US on 1. So whenever I am taking generalization to a specific one, the variable should also have been changed. So it is H of A conditional M of A. Then I have the one more premises, there exists X, H of X, that is rule P. And next is, I will have to remove this there exists X. So if I want to remove this existential quantification symbol, it is ES on 3. So ES on 3, what do I get? H of A. So now see to this, no, we have P conditional Q. P conditional Q, it gives Q. What is the law called? The law is detachment. So detachment on 2 and 4. Detachment on 2 and 4, what do we get? M of A. So now see to the conclusion part. Conclusion, we have the quantification symbol as existential. So now we are generalizing it. So generalizing it with the quantification symbol existential. So it is EG on 5. So therefore we have there exists X, M of X. So that is what the conclusion part of the problem. Here ends the matter. So one has to be very thorough with all the rules of inference as well as with the laws of implication and equivalence. So unless otherwise one is not thorough with these things, we cannot do anything at all. So now here we will see few more problems. Use indirect proof method and prove that this implies this. So, they have mentioned the method here. So, if it is just prove that either one of the method we can make use, that is either I can make use of direct proof or I can make use of indirect proof. So, here in this problem they have said that use only the indirect proof method and get the conclusion. So, definitely I will have to go only by indirect proof. So, indirect proof as what I have said earlier already, it is we will have to consider the first and foremost step as what? Negation of the conclusion. And negation of the conclusion has to be considered as one of the premises along with the given other premises, and then your final conclusion must be the contradiction F, right. So, let us see serial number, statement, explanation. Let us see whether we get it to be a valid statement or not. So, first step is negation of the conclusion. Negate of for all x, p of x or there exists x, q of x. This is rule P, right. Now, next is I will have to apply the De Morgan's law. So, apply De Morgan's law on 1. So, whenever we interchange the quantification with the negation, the quantification symbol will be changed. So, therefore, its complementary part will be negation, there exists x, negation p of x, or becomes and this becomes for all x and q of x. Again here we will have to remove of these two quantifiers. So, simultaneously I can apply for this, it is ES on 2 and this is US on 2. That is, I am applying existential specification as well the universal specification simultaneously on this step. So, if I apply simultaneously, I do get this to be as negation P of A and negation Q of A, right. So, now this will be, I can go by conjunctive simplification. Conjunctive simplification on 3, we can have it to be as not P of A, and here we can have it to be as not Q of A. So, this is conjunctive simplification on 3. Then we are left with this premises, we will take that for all x, P of x or Q of x, right. So, that is rule P. So, now again even before I apply any of the laws of implication or equivalence, I will have to remove of this, that is universal specification on 6. So, we get this to be as P of A or Q of A. So, again, so if I have somewhere the connective as conditional, it will be better for me to apply any of the suitable laws. So, that I can bring this to be a conditional statement if I apply what? Conditional equivalence on 7. So, I do get this to be as not P of A, conditional Q of A. And look at this 4th and 8th statement, no, we have not P of A and here not P of A, conditional Q of A. So, I can apply the law of detachment, and if I apply law of detachment to 4 and 8, right. So, law of detachment if I apply to 4 and 8, we get it to be as just simply Q of A. And with that, our intention is to get the conclusion part as F. How do we get the conclusion part as F? See here, I have the 5th step and the 9th step. Just take the conjunction of these 2 steps, right. Conjunction of 5 and 9, what do we get? So, the conjunction is Q of A and negate Q of A as the conjunction of this, and we get this to be as F, and that is nothing else but the contradiction. That is what we need to get it. So, using this indirect proof method, we have got the final conclusion to be as F, right. So, we will have this problem and we will fix up this to be the last problem of this today's video session. Show that from there exists x, f of x and s of x, conditional for all y, m of y, conditional w of y, and also negation, there exists y, m of y and negation w of y. The conclusion is for all x, f of x conditional, negation s of x, right. So, now we will go step by step, and this is trickiest problem we have. We will take the first premises as it is, right? We will take the first premises as it is, that is, there exists x, f of x and s of x, conditional for all y, m of y, conditional w of y. So, that is rule P. Right, we have taken the premises as it is, and we will have to simplify as far as we can, right, and also we are left out with only this premises. Fine. So, now I will have to remove off this quantification symbol and all. So, I have two quantifications, existential as well as universal, and I can write this to be as ES and US on 1. So, ES and US on 1, I have two different variables, right. Keep that also in mind. Whenever we change it, I should change it to some other specific object. So, I will have here to be as f of a and s of a, right, x, and I have y now. For that y, I try to have some other variable, that is m of b conditional w of b. So, third point is that f of a and s of a conditional m of b conditional w of b. Now, see to that we have got this part, right, we have got this part to be the second premises. So, what we can do is that try to convert this term into a term of this form, so that we can apply modus tollens and we can get it somehow. So, that is f of a and s of a conditional. I can apply here what can I apply here? I can apply conditional equivalence. So, conditional equivalence, if I apply on 2, what do I get for this term alone? Negation m of b or w of b, we will get it. And then, so here m of y and I have. So, parallelly you just look into the other premises also, so that you get the correct conclusion with the minimum number of finite steps. So, we will have f of a and s of a conditional. See, here we have and, but then here we have or. So, I will take negation here, negation. So, that this becomes m of b and this or becomes and this becomes negate w of b. So, I have taken negation here on the third step. So, after that, see here what can be done. Okay, see m of b, m of y, and this is as it is. Okay, fine. We will go on for the second one, right. Second premise is there exists y, m of y and negation w of y, that is rule P. Now that we will have to remove off this existential quantification symbol. So, ES on 5, and see to that the variable is y here, the variable is y. So, that I have taken a next specific object to be as b. So, that I will have to take it as m of b and negate w of b, right here. So, now the next step, see here I have got m of b, and whenever we have right, say for example p conditional q and negate qb, sorry q, right. Whenever we have negate q and p conditional q, this will imply negate p, that is modus tollens rule. Modus tollens rule. In a similar manner, see here, no, treat this as one single particular predicate term. So, this is like a p conditional negate q, and here we have this term, right. So, whenever we have this now, we will write it to be as negate p of a. Here it is negate q, and here we have this term. So, therefore, what we get is that if see here it is of the form p conditional negate q, p conditional negate q we have, and q we have here, right. So, this and this will get cancelled, we get negate p. I cannot, can I apply that law here? Can I apply it? Yes. So, now we can write apply this and write to be as negate of this term, right, negate of this, negate of p. So, negate of p is what? Negate of P is f of A and S of A. That is modus tollens I have applied for what is that step? 4 and 6, modus tollens on 4 and 6. So with this I can apply the De Morgan's. If I apply the De Morgan's, we will get it to be as negate f of A or negate S of A. And again I see to the conclusion part. The conclusion part is something like f of x conditional. So conditional has to be brought in here. So that is conditional equivalence on 8 we can apply. Conditional equivalence on 8, if we apply it, what do we get? We have f of A conditional negate S of A. See to the conclusion part? Yes, but then there it is generalized with the universal quantification symbol. Universal generalization on 9 we get A has to be replaced by x. So therefore for all x we get f of x conditional negate S of x. So that is our conclusion part. There ends the matter. Understood now? So hope we have done umpty number of problems in order to have a better clarification of under the rules of inference, either by direct or by indirect. So with this I hope everybody will be able to get somehow the conclusion part of the given problem, or somehow you can get the statement to be as valid or invalid. Thank you.